Welcome back. This is the second video in the mini pizzas and calzones project. This should have been where we left off or something similar to this. And so in this video, we're going to actually solve the problem. You know, we have these restrictions that we haven't talked about. So let me go to the PowerPoint really quick. So here is the original PowerPoint that I gave you. So we know that we have this restaurant, we sell pizzas for 5, calzones for 7. We want to maximize the revenue, but we've got some restrictions. Now I highlighted the 10 and the 6 because in the last video I had these numbers reversed, and so that was a mistake. The pizzas take 10 minutes of labor to produce, take a little bit longer than the calzones, which take 6. The baking time restrictions are the same. So how do we use this to solve the problem, which was assuming that all the pizzas get bought, how many should we produce to maximize the revenue? So we'll start off. In the first video, we did this formula. In the second video, we're going to work with the labor and baking time restrictions to find an answer to this problem. So here are the labor time restrictions. So let me start the slideshow from here. So we know that the pizzas take about 10 minutes of labor time to produce. Calzones take 6 minutes. And so what we like to do is be able to come up with the formula that represents this so that we can use Excel. So we're going to let X, again, represent the number of pizzas, of mini pizzas. So that means when we multiply 10 and X, well, 10 is how much time it takes for each pizza to be made. So 10 times X is the amount of time that it takes to make X number of pizzas, whatever X is. So for example, if X is 5, well, if you had to make 5 pizzas and it took 10 minutes each, then 5 times 10 is 50. So it would take you 50 minutes to make 5 pizzas. Same here, Y represents the number of pizzas. And so if you know how many pizzas, for example, oh, sorry, this is supposed to be calzones, not pizzas. If you knew that Y was the number of calzones, then 6 times Y. So if you had 2 calzones, 6 times 2, it means it would take you 12 minutes to produce Y calzones. And so a formula that takes this into account is we would need 10 times X, that's the number of pizzas, that's how much time it takes to make the pizzas. 6 times Y is how much time it takes to make the calzones. But we only have 480 minutes total of labor time, so this is less than 480. And we need Excel to be able to do some math for us. So in this case, we do need a little bit of algebra to help us. And so this is what we're going to do. We're going to take this inequality, and then we're going to solve for Y. And in fact, we're going to make it an equal sign because it'll be easier. And then in the last 2 weeks of class, we'll learn about graphing these inequalities. But for right now, this is as much as you need. So we have this equation. This is a linear equation. Hopefully you know this. And we're going to solve for Y. So you know, and you might want to pause the video now and try it yourself, and then look for the answer later. Okay, welcome back if you pause the video. If not, we're continuing. If you want to solve for Y, the first thing you do is subtract 10x. So you should get some from both sides. So you should get something like this. And the next thing you'd like to do is probably divide by 6. Everything divided by 6. So you'd probably get something like this. And so that Excel doesn't have too much of a hard time, we'll simplify a little bit. And so this would actually look like this. Negative 5/3 x plus 80. This is the formula that we're going to use in Excel. And so I'm going to go ahead and exit out of here. Copy this. You don't have to do this. I'm just going to do it on this slide so that it'd be easier for us to see. So here was the last formula. Let me put this here. This is the next formula. We'd like to be able to make a table of values with this and maybe graph this. So let me make here on A14, if you can type number of pizzas. And this is X. And then here we're going to type the largest number of calzones, Y, second, given the labor time restrictions. And so I'll explain what this means in a minute. So according to this formula that we just produced, and I'm going to resize my columns again like I always do just to make it all fit. So if I produced only 0 pizzas, then this number means, according to this equation that I'm highlighting right now, if I produce no pizzas, I should take into account the restriction I have for labor time. Remember, I can only do so many. I should be able to produce 80 pizzas. Okay, and so we're going to let Excel do the math for us. So it's going to be equals negative 5/3. So I'm going to put it in parentheses. Negative 5/3, 5 divided by 3, times, and then X is the number of pizzas, so times 0 plus 80. Now, this formula tells you how many, if it relates the number of pizzas to the number of calzones you can produce, given the fact that you only have so much time. You only have 480 minutes. So if you produce one pizza, you could produce at most 78.33 calzones. And you know it's not going to be 78.3. 78 would be the most. And if you could make two pizzas, then at the most you could do 76. Again, not a real time value, but it's the best we can do. And then if you do three, and so on and so forth. So notice that we would only get positive values or real values for the number of calzones if we have multiples of 3. So we're going to do this. We're going to go ahead and put the number of pizzas here, and we're going to go up by 3, 6, 9. But this is going to take a while. We want Excel to do this for us. So instead of having to type it all in, let's go ahead and delete this. Let me show you what Excel can do for you. You can type it, you can tell it to do what you want. You say equals, take the number above and add 3 to it. And sure enough, it does that, but it gets even better. If you go here to the small corner and you drag down, it actually knows what you want. It knows you want to go up by 3. Okay, so here, notice that if you look at the formula bar up here, it sort of said, it guessed that you wanted to add the number above it and add 3 to it. If you look at, if you look over here at the 12, it says take the number in A19 and add 3. So Excel tries to guess what it is that you're trying to do. Let's go ahead and go down to about, okay, let's try this. Let's go a little further. I want to get down till it says 48. You'll see why. Well, let's go down a little further. All right, here we go. Now, I want Excel to calculate formula. I don't want to type in the formula every single time. So I'm going to go ahead and drag, and I'm going to hope the formula gets copied. And sure enough, notice what it does here, if you look at the formula for 75, it says let's take -5/3. Let's multiply it times this 3, the A17, and then let's add 80, and it's able to go. Now, here's where domain and range sort of makes sense. Notice that I can't make any negative pizzas, so pizzas have to be at least 0. So that's the domain. The domain has to be at least 0. But I shouldn't really make more than 51, because if I make 51 pizzas, that means I have to make -5 calzones, and that doesn't make sense either. So the domain of this function is actually going to be, let's delete these two, from 0 to 48, because anything more than 48, so even 49 doesn't make sense, because you get negative pizzas, or negative calzones. So this is why it's important to know about domain and range. And the range, notice, well, the most we can get is 80 pizzas, and the least we can, calzones, and the least we can get is 0. And so that's why we need domain and range to understand this function. This function, you know, is a line, but it has some restrictions. The pizzas can only go from 0 to 48, and the calzones only from 80 to 0. Okay, so we're going to do the same thing with the other restriction. So let me go back to the slideshow. Actually, let me go down one. And let's start from here. And so again, pizzas take 4 minutes to bake. Calzones take 6 minutes to bake. We only have 426 minutes, and we want to represent this. And so x is the number of pizzas. 4x is how much time it takes to bake the pizzas this time. Y is the number of calzones. I made a mistake again. I apologize. And 6y is the amount of time it takes to make such calzones. And the formula for this would be, well, 4 times x is how much time it takes to make pizzas, bake pizzas. 6y is how much time it takes to bake calzones. And so we have a total of 426 minutes. And again, we're going to use, Excel's going to help us with this, and we're going to solve. And so again, if you want to pause the video at this point, it's okay. Solve for y. Okay, hopefully you're back. If you solve for y, you probably subtracted 4x on both sides. Then you divide it by 6. And then you hopefully reduce so that Excel doesn't have to work so hard. So this is the formula we want to use with Excel. And so let me copy and paste this. Oops, I don't think I copied correctly. There it is. All right, what I'm going to make though is I don't want to create a new column for number of pizzas. We already know the number of pizzas. And notice that since it's 3, it's good to go up by 3. So let's type in here largest number of calzones. So let me just copy and paste, make this bigger. And then here it's given baking time restrictions. And we're going to do the same thing we did last time. So I'm going to press 0. So this is equal to parentheses -2 divided by 3 times the number of pizzas plus 71. And then, of course, if you highlight this and go down, we should be able to go down all the way to 48. In fact, we can go down even further if we wanted to. Uh, I would just have to change this. We can go even further. So the domain is a little bit longer for this, and so is the range. And so let me continue a little bit further to see how much. So we're going down by 2, so I can probably do just a few more. And then after this, it'd be 0. So the domain for this function could get negative. In fact, if we do 106, I think, oh, that 106 is fine. We can't do a third, though. And 107 would be negative. So yes, 105 is the most we can produce. And so the domain is from, for this function is from 0 to 105, and the range is from 71 to 1. And this is as far as we're going to go. I'm going to go ahead and pause this video, and I will have the third video up soon.